So 8.1b, we're going to talk about dividing with radicals today. So for number 8, I'm given the square root of 30 divided by the square root of 5. Okay, so whenever I'm dividing by radicals, if I'm wanting to fully simplify my answer, the thing that I'm trying to go for is I'm trying to get this radical, the square root, out of my denominator. Okay, so normally we'd see one way of doing it. Here's another way we can look at it. So square root of 30, I can break this thing down into the square root of 6 times square root of 5. Okay, so if I've got two things that can multiply to give me that 30, I can make that into one radical and then split it into 2, which is what I did right here. So now if I've got square root of 6 times square root of 5 over square root of 5, then these square roots of 5 will cancel each other out. And so the only thing I'll have left is the square root of 6. And since I can't simplify the square root of 6 any further, this is going to be my final answer for number 8. Now number 9, we'll see it use a different way to get this denominator without a radical. So on number 9, I'm given the square root of 7 divided by the square root of 3. So this time, since I can't really break 7 down into anything to get rid of that square root of 3, I'm going to multiply by 1. But I'm going to multiply by 1 that looks a little bit weird. Okay, so remember, anything can be 1. Okay, so 1 can look like 1 over 1, 2 over 2, 5 over 5. It can also look like the square root of 3 over the square root of 3. Okay, so this whole thing is 1. So if I multiply my top to my top and my bottom to my bottom, I'm going to get the square root of 7 times 3, which would be the square root of 21. I'll get the square root of 3 times 3, which would be the square root of 9, which I can then simplify to just 3. And since from here I can't simplify this any further, I'm going to get the square root of 21 divided by 3.